A flip video about the combined gas law. So as a review, it is important to remember all the laws that we've talked about so far for gases. Here they are. We've got Charles, Boyle's, and Gay-Lussac. And if you notice in Charles we have temperature and volume, and for Boyle's we have pressure and volume, and for Gay-Lussac we're talking about temperatures and pressures. So let's try to see if we can see some commonalities amongst these equations. What are some things that you notice that are the same? So if we look here, anytime I see volume, it is in the numerator. Volume on top in the numerator, volume on top in the numerator. Anytime I see temperature, it is in the denominator. Temperature in the denominator, temperature in the denominator. And anytime I see volume, I think I said volume already, pressure, we see pressure, pressure's in the numerator, pressure's in the numerator. The other thing I notice is that all of the ones initial conditions are on this side of the equal sign, and all of the twos are on this side. So the combined gas law takes all of these laws and just combines it into one law. So it's nothing new. It is just taking our old laws and combining them together. So let's see how we would do that. If we take a look at the first one, we have to make sure our V's are on top. See, here they are again, V's on top. Okay? And we have to also make sure our P's are on top. So our P's are on top, right? So with that being said, here's my combined gas law with our P's and V's on top. P1, V1 on top, P2, V2 on top. And then if you notice, my T's have to be on the bottom. And here are my T's on the bottom. This is the combined gas law. Again, all the ones are on the left-hand side and all the twos are on the right-hand side. It is all of these laws just combined together. Now, some things we should remember that are true for all gas laws. For this entire chapter, you have to remember to convert your temperature to kelvins. So here's the equation once again, degrees Celsius plus 273. Before you begin, you should convert. Do not convert at the end. The equations don't work if you use degrees Celsius. Now, how about the other units? Well, it doesn't matter what units you use for the other variables. Let's write that down. So we know temperature must be in kelvins, but what about the pressure units? It doesn't matter as long as they're the same on both sides. So if this pressure is ATM, then this pressure needs to be ATM. Or if you had mmHg on this side, it just needs to be mmHg on this side. Same thing for volume. It doesn't matter if your volume is liters here, as long as it's liters over here. It also doesn't matter if your volume was milliliters here, as long as it's the same on that side, milliliters. So the combined gas law is not very picky when it comes to units. All right, so let's take a look at a problem. A gas, remember we're talking all about gas laws, so we're talking about a gas, has a volume of 15.3 liters at 25 degrees Celsius and 1.11 ATM. What is its volume at STP? STP is an old topic that's coming back, and if you notice, we've been talking about it a few times this semester, so it's always important to remember what STP is. We'll get to that in a second. So before we get to that, let's see what we have. We have a gas, and it has a volume of 15.3, a temperature, and a pressure. So let's go ahead like we always do and list our variables. I put my volume, given to me first as V1. My temperature, I converted it to Kelvin, adding 273. And my pressure, remember pressure, unit ATM, here it is. What is the new volume at STP? It appears like we don't have any more information. So where in the world would we get all of our second set of variables? The twos. Okay, well we know that they're asking what is the volume, so we know volume is our X. But where do we get our temperature and pressure in the final state? Well, this gas goes from these conditions to conditions at STP. So you have to remember what STP is. Here's a refresher. And you should have this in your notes already, but it's always good to write it down again. STP is standard temperature and pressure. It is a standard we set to look at gases sometimes. And that standard is 0 degrees Celsius and 1 atm. That is your temperature and pressure if you're at a condition known as STP, which you are in the problem. So why don't you add that now into your variables? So now this gas has changed to be at STP. STP is 0 degrees Celsius, but I have to convert it to Kelvin. And the pressure is 1.11 atm. Oh, I'm sorry. 1.00 atm. I got those conditions from STP. Now all we have to do is plug in our variables into our equation. So again, here's my equation, a little bit hefty. I have to plug my pressure into my pressure, my volume into my volume, my temperature into my temperature, and same thing for the other side. So let's begin. All I did was I created just some parentheses to help me remember where things go. All right? You don't necessarily need parentheses, but it might help you. So my P1 goes up on top. Don't forget your units. Right? My V1 goes next to it. And my T1 goes on the bottom. Don't forget it has to be in kelvins. On the right hand side, my P2, which is 1 atm. My V2, which is X, divided by my T2, which is 273 K. Has to be in kelvins. Okay? Next, watch my algebra, because when you do your algebra in the way I'm going to show you, it's going to minimize your rounding and any errors that you have, and it's also going to force you to do sig figs once at the end, which is the goal. So you might be used to doing your algebra in a different way, but this is the way I would like you to do it. So watch my algebra. The first thing I'm going to do is I'm going to cross multiply. So let's go ahead and show that by circling our two parts that we're going to cross multiply. Okay? So when I cross multiply now, I'm going to write this as 298K, don't forget your units, times 1.00 atm times X. That's on that side. Equals, and now I'm going to add or multiply all of those things together. The 1.11 atm times the 15.3 liters times the 273K. Okay, I'm not going to simplify yet. Again, watch my algebra. I'm going to now solve for X. Divide by 298K times the 1.00 atm. Divide by the 298K times the 1.00 atm. These cancel out, these cancel out. This cancels out, this cancels. So I'm left with X on this side. Now, why did I do my algebra this way? Because I can put this all in my calculator in one shot and get one final answer that I round only at the end, and I do my sig figs only once at the end. That's the goal. So let's go ahead and try this right now. Pull out your calculator. The goal is you have to do 1.11 times 15.3 times 273 divided by, now put this whole thing in one big parentheses as seen here, 298 times 1 atm. Okay? When all is said and done, please follow along and try to do this. You should get 15.6 liters. Now let's check our sig figs. 3 sig figs, 3 sig figs, 3 sig figs, 3, 3. Well, my lowest is 3 sig figs. So there you go. There's your answer. Now let's make sure we see the units cancel out, K and K, ATM and ATM. Liters is left over. That's why I have liters. If these units don't cancel out, something is wrong. So please make sure and check your units all cancel out. And that's how you do combined gas law.